Hello my dear students and welcome once again to Zenith Academy Online. Today we are doing a very important chapter sound and we are doing part 1 of this chapter sound where I'll teach you about waves, about longitudinal and transverse waves, what is amplitude, time period, frequency, wavelength, wave velocity, all these terms I will explain you, and then we will do characteristics of waves. Because before starting with the sound, you should be familiar with all these terms and you should know all these terms very well. That is why we have started with this. So let's go ahead. What do you mean by a wave? What is a wave? So before studying sound, you should know what is a wave, what are the different types of wave, which type of wave is sound wave, and what are the different terms that we use. So what is a wave? A wave is produced by vibrations. Wave कैसे produce होती है? When there are some vibrations. Vibrations of what? Vibrations of the particles of the medium through which it passes. So wave is produced by vibrations of the particles. So if wave is passing through air, then the air particles will vibrate. So a wave is produced by vibrations of particles of the medium through which it passes. Now when a wave passes through a medium, the medium itself does not move. Now the air is not moving. The air only moves. Okay, air does not move along the direction of wave. Only the particles of the medium vibrate about their fixed positions. So when a wave passes through a medium, the medium itself does not move. Okay, along the direction of the wave, only the particles of the medium will vibrate about their fixed positions. I will explain you this in detail when we are doing different types of waves. So that was the explanation of wave. Now the exact definition of wave. A disturbance or vibration that transfers the energy progressively from one point to another in a medium without there being a direct contact between the 2 points is called a wave. So what is a wave? Wave is a disturbance or a vibration which transfers energy progressively from one point to another. Okay, so when there are different points here in a medium, so this particle is vibrating and transferring its energy to this particle. This again vibrates and transfer the energy here. So energy is transferred like this from one particle to another. So a disturbance or vibration that transfers energy progressively from one point to another in a medium without actually there being a direct contact between the 2 points. There is no direct contact between these 2 points. Okay, this is called a wave. Now there are different types of wave. First is mechanical wave and then you have non-mechanical wave. Okay, so in mechanical waves, we will be talking about transverse waves and longitudinal wave. Here I have given you the diagram of transverse and longitudinal so that you understand here itself. So now let's begin with mechanical waves and let's understand what is transverse and longitudinal waves. So see, mechanical waves. Mechanical waves are those waves that require a material medium for their propagation. What do you mean by propagation? Traveling. So when the wave has to travel, okay, then if the wave is requiring any material medium, what do you mean by material medium? The medium can be solid, liquid or gas. Okay, vapors. So those waves which require a material medium for their propagation are called mechanical waves. The other name of mechanical waves is elastic waves. So what are the example of mechanical waves? Sound waves, water waves, waves on a stretched string and so on. These are the examples of mechanical waves. I hope you have understood. So when there are sound waves, when I am speaking and you are listening, okay, the air between me and the listener, okay, so the air between me and right now the voice recorder, okay, is vibrating, and since there is air in between, then only you are able to hear me. So if I was speaking in a vacuum on maybe on some other planet where there is no air, okay, then you would not listen to, you would not be able to listen to me because sound waves are mechanical waves. For transfer, they require a medium like air. Okay. Now, what are non-mechanical waves? Non-mechanical waves are those waves that do not require any material medium for their propagation. They can even travel through vacuum. For example, light waves. Okay. So, in the solar system, there is no, if you go in the space, okay, light is coming to earth from sun and there is no air in between, but still light is able to travel and come to us, right? So light is a non-mechanical wave because it does not require any material medium for its propagation, for the travel. Example, all the electromagnetic waves such as light waves, radio waves, X-rays and so on, they do not require a material medium for their propagation. I hope both the things are clear. So now let's talk about two types of mechanical waves. Okay, we'll talk about two types of mechanical waves, which are longitudinal and transverse. So let's first talk about longitudinal wave. We'll be talking about longitudinal wave most of the time in the chapter sound. Okay. So a longitudinal wave is that wave in which the particles of the medium vibrate about their mean position along the line of direction of propagation of wave. Now you see here the wave is traveling like this. So this is the direction of propagation. This is the direction of travel or direction of propagation. So if I take this equilibrium, can you see this equilibrium? If I take this mean position, so can you see this pink line? It is traveling, it is going like this and this, okay, around the equilibrium. So it is vibrating in this direction only, this or this. So these two lines are along the direction of propagation. This is the direction of propagation and this is the direction of propagation. So this is also like this or this. So the angle between them is 0 degree. Okay, they are parallel. The direction of propagation and the vibration like this and this. These two lines are parallel to each other. Are you getting me? So in the longitudinal waves, how do the particles of the medium vibrate? The vibration of the particles of the medium is in the same, is along the line of direction of propagation of wave. So both these directions are parallel. So longitudinal wave is composed of compressions and rarefactions. So if you see here carefully, there is some region here. Can you see this region which is compressed, and there is a region, this region is called rarefaction. Okay, I'll talk about compression and rarefaction in detail in the next video. Right now you just have to understand what is a longitudinal wave in which the particles vibrate like this and the direction of propagation is also like this. So both of them are making an angle of, okay, both of them are like this. So it is making an angle of 0 degree. They are parallel and it is composed of compressions and rarefactions. So what are compressions? When the wave is very close by. Rarefaction is when the density is low, the waves are like this. This is again a compression. This is a rarefaction. We'll talk about compression and rarefaction in the coming classes. Now, so if you take a spring, okay, and you stretch it and release it, you will understand the compression and rarefaction very well. So compression is the region of high pressure and low volume. Okay, see the volume is less, less volume, high pressure is there, density is high. Can you see? Density of the particles is high. Okay, volume is low and pressure is high. Pressure is high in the compression. Whereas in the rarefaction, it is covering larger area. So the volume is more. Volume is more. Density is low. Density is low and pressure is also low. I hope you have understood. Rarefaction is a region of low pressure and high volume. Now let's talk about transverse wave. We have understood transverse waves before also in our earlier classes. From the childhood, whenever we are told to make waves, we make waves like this, isn't it? So we have always been making transverse waves. So what is a transverse wave? It is that wave in which the particle of the medium vibrate about their mean position. This is mean. At right angles to the direction of propagation of wave. So here if you see this red dot, how is it vibrating? At this position only, if I draw a line like this, at this position only it is going up and down. Can you see? The red dot, it is going up and down on this position only, isn't it? So the particle is vibrating like this or this, and direction of motion of the wave is like this. So this is the direction of motion. So they both are at 90 degrees to each other, at right angles to each other. So those wave in which the particles, the vibration of particles, this is vibration of particles. So the direction of vibration of the particles and the direction of propagation of the wave, if both of them are at right angles to each other, then this type of wave is known as transverse wave. So it is composed of crest and troughs. So if you see this top region, if I make a wave like this, okay, then this region is known as crest, the top region, and this region is known as trough, T-R-O-U-G-H. Okay, so transverse wave is composed of crests and troughs. Crest is a position of maximum upward displacement. So this red dot, maximum when it goes up is this, right? This is the maximum displacement from the mean position. This is the mean position. This is the mean position. So maximum displacement is crest, position of maximum upward displacement, and maximum downward displacement is trough. This is trough, T-R-O-U-G-H. Trough is the position of maximum downward displacement. I hope you have understood longitudinal and transverse wave very clearly. If you have any doubts, you can keep on writing in the comment section. And if you are wondering from where I have made notes and from where I have made this PPT, so this is an amazing book by Oswal Gurukul, ICSE Certificate Physics. Okay, amazing book by Lishi Kalyan and Dharmendra Pant. These are the authors, and it's an amazing book where all the details of the chapters are given with nice pictures and tables and everything. Okay, I'll give you the buy link of the textbook in the description box. Let's go ahead. Now let's talk about the terms related to wave motion. So first term that we will talk about is amplitude. So now whenever I am explaining you all these terms, I am taking this type of a wave so that it is easier for you to understand. Okay, I am taking transverse wave to make you understand the terms. So amplitude. What is amplitude of a wave? It is the maximum displacement of the particle of the medium on either side of the mean position. So if you see, this is the mean position. When the medium is not disturbed. So this is the mean position. Now when the medium starts vibrating, when the wave is created, the medium starts vibrating. So now the particles will go up and down in this case, or it will go sideways in the longitudinal one. Okay. So in the transverse wave, the particle will move up and down. In the longitudinal wave, it will go like this. So right now, this was the mean position. This is the maximum displacement. And this is also the maximum displacement. This is maximum upward displacement. This is maximum downward displacement. So this portion, okay, this distance is known as amplitude, which is denoted by small a. This distance is amplitude. Okay, can you see the distance? This distance from the mean. This is known as amplitude. Okay, so amplitude is the maximum displacement of the particle of the medium on either side of the mean position. This is also amplitude and this is also amplitude. Okay. Now, next is time period, which is denoted by capital T. So it is the time taken by the particle of the medium to complete one oscillation or vibration. So if this is a wave like this, okay, so what do you mean by one vibration? Okay, I'll take another color. So from here to here, this is one wave. Okay, so the time taken by the particle to complete this one oscillation or one vibration, okay, or the time taken by the particle to reach from this point to this point in different phase. So time taken by the particle to complete one oscillation is known as time period, which is denoted by capital T. Okay, time taken, not the distance. Now what is frequency? Now this is not V, this is mu. We call it as mu. Okay, mu. So it is the number of oscillations completed by the particle in 1 second. Now here the time is fixed. Okay, so now in 1 second how many oscillations are done? Okay, so in this case more oscillation will be done in 1 second. In this case less number of oscillation will be taken in 1 second. So how many oscillations have been completed in 1 second is known as frequency. Okay, which is given by the symbol nu. Nu, sorry, not mu, nu. Okay. Now we are talking about wavelength. It is denoted by the symbol lambda, like this and this. Okay, lambda. This is how we pronounce it. L-A-M. Sorry. Lambda. Okay. So what is it? What do you mean by wavelength or lambda? It is the distance measured in the direction of propagation of wave between two successive points in the wave that are characterized by the same phase of oscillation. Now see here, if I take a point here and if I take a particle here, so these particles are in the same phase of oscillation, right? So this is also at a maximum displacement. See, if I explain you like this, the particle was here. The particle is moving like this. Okay. See, this particle is not moving. There are different particles. So particles are moving up and down, up and down. So this particle, particle number 1 and this particle, they both are in the same phase. Okay. So the distance between them is known as wavelength. So if I take some other particle now, let me take some other particle. Suppose I take a particle which is here. And this particle is again also in the same phase. So the distance between them. If I take a particle like this and a particle like this. So the distance between them. So the easiest way to measure this is the distance between two crests is known as a wavelength. Okay, because these are particles in the same phase of oscillation. Or the distance between two troughs is also known as a wavelength. Otherwise, you can take any point like this also here. This particle and this particle are in the same phase of oscillation. So this is also one wavelength. Have you understood, children? What is a wavelength? In simple words, you can say distance between two crests or distance between two consecutive trough. है ना, पास वाले crest और पास वाले trough, या फिर the distance between two successive points in a wave that are characterized by the same phase of oscillation. This is wavelength, which is denoted by the symbol lambda. So now if you see this one and this one, what you can see here, they are very close by, है ना, the waves are very close by. So the distance between two crests, if you see, is very short. So this is shorter wavelength, and here if you see these 2 points, same phase of oscillation, the wavelength are longer. Okay. Now we are talking about wave velocity, which is given by small letter v. This is small letter v. Okay. It is the distance travelled by the wave in 1 second. So suppose a wave is like this. Okay. So suppose in 1 second, okay, in 1 second it is traveling this much. In 1 second it is traveling this much. So what is the distance that it has travelled in 1 second? What is the distance that it has travelled in 1 second is known as wave velocity. Anyways, we know what is speed. Speed is equal to distance by time. Right? So what is wave? If I talk about wave velocity, what is velocity? Velocity is how much distance it has travelled in 1 second in time. So it is the distance travelled by the wave in 1 second. Velocity, wave velocity is the distance travelled by wave in 1 second. I hope this is clear to you. Now, so just revising it with this. Okay, I have explained you every term with transverse waves. Example are visible light. So this is how transverse wave we are able to see. okay, because of transverse wave, and longitudinal waves is mostly in case of sound. So you see here the particles are vibrating like this, the source is vibrating like this, and in this the source was vibrating like this. So the amplitude, what will be the amplitude? See here the amplitude was maximum displacement, है ना? Here what will be, see what will be amplitude maximum, how much it is going. Okay, so here it is so difficult to explain amplitude here in this longitudinal case. Okay, but wavelength we can explain. This is compression, right? So the distance between two consecutive compression is a wavelength. The distance between two consecutive depressions is a wavelength. Okay, that is how we will explain this. And this is the direction of propagation. The source was also like this, so the angle is 0 degree. Here this is the direction, the source is vibrating like this, so the angle is 90 degree. You have to remember longitudinal and transverse wave really well. Okay, I hope this is clear. Here we talk about crest and trough. Here we talk about compression and rarefaction. So see here, these are different compressions. These are rarefactions. So the distance between two compressions is the wavelength. This is a wavelength. And if I take the center point of here and a center point of here, this is also wavelength. Clear to you guys? Chalo. So now we'll talk about relationships. Most of the time 2 mark or 1 mark question comes from this. Okay, in MCQ or something it can come. Okay, relationships. So first relation is relation between time period and frequency. So this frequency is equal to 1 upon time period, or I can say time period is equal to 1 upon frequency. Now sometimes frequency can be denoted by small letter f also. So frequency can be 1 by time, or time can be equal to 1 by frequency. Because what is frequency? What is frequency? है ना? How many waves in 1 second? So 1 by time period. Okay. Now relation between wavelength, frequency and wave velocity. So this is the relationship. Okay, nu is equal to v into lambda. Okay, so this is what? This is frequency. Frequency is equal to wave velocity into wavelength. Okay, this is the relation. But how we arrived at this relation? Let's see how we arrived at this relation. See, I am showing it to you here. Okay, we know what is speed. Speed is equal to distance by time, or we can say velocity is equal to distance by time. So I'll write velocity here better. So velocity is displacement or distance by time. Now distance divided by time ki jagah I can write distance into 1 by time. This is also okay. Okay. So wave velocity is given by small v. Distance is given by wavelength. Length is distance. Now 1 by time. Just now I explained you 1 by time period is nothing but frequency. So this is frequency. So this frequency, velocity. So this is equal to, there is between wavelength, frequency and wave velocity. Maybe I have written this wrong. Yes, I have written this wrong. This is V is equal to lambda into frequency. I am so sorry. I'll just check it also once again. The relationship. Maybe I have, I have written it wrong. So this is V is equal to, good that I derived, nu into lambda. Okay, I will write here wave velocity is equal to frequency into wavelength. Okay, so please note that the earlier one was wrong and I have corrected it just now. Clear? Now, last question for today is characteristics of waves. Wave के क्या characters हैं? So, first point is, we have already done all this. When energy is transferred to any part of the medium, then disturbance is produced in it. Okay? How the disturbance is produced? By the periodic motion of the particles about their mean position. So, particles in this case vibrate like this, and in this case it vibrates like this around the mean position. So, either the particles vibrate like this around the mean position, or it vibrates like this around the mean position when energy is transferred. So this is the first characteristic of wave, that when energy is transferred to any part of the medium, then disturbance is produced in it by the periodic motion of the particles about their mean positions. Next, the energy moves forward in the form of waves while the particles of the medium oscillate about their mean position. So you have to remember what moves? The energy moves. But particles of the medium, they just keep on oscillating about their mean position only. Okay. So here if you see this red line, it is vibrating about the mean position. Here in the second one, if you see the red dot, it is vibrating like this about the mean position, up and down. But what is moving ahead? The energy is moving ahead. Okay, energy is moving ahead. That is the second characteristic of wave. So all these characteristics, if you understand, then only it will become easier for you to understand the sound chapter very well. The velocity of wave is different from the velocity with which the particles oscillate about the mean position. So I am saying that the wave is going in this direction, and I am saying the particles are either vibrating like this or vibrating like this. So the particles vibration velocity is different than the velocity of the wave. You have to remember that these two velocities are not same. So the speed with which the particle is vibrating is different with the speed with which the wave is moving. I hope now this is clear. Now next is, energy is transferred from one particle of the medium to the next particle in a fixed time. That is, energy is transferred at a constant speed. So the time of transferring the energy, if the time is fixed, so the speed becomes fixed, the energy is transferred at a constant speed from one place of the medium to another place. And there is a constant phase difference between two consecutive particles. That is why if I say if this is a wave, okay, so this phase of this first and this is the second, so this remains constant. And this remains constant phase always. So in our next videos, we are coming up with sound waves. I will explain you sound waves, what is the difference between light waves and sound waves, and how does sound propagate, how does sound travel from one place to another. So we are coming up with this next lecture in this part 2 of this video series. So for your information, this is the book that I use, ICSE Certificate Physics for class 10. Okay, I will give you the link of the description box, in the description box about this book. And if you want to do questions, okay, so you can use this book. In this book, there is category-wise and chapter-wise questions. Chapter at a glance is given to you, word of advice by experts given to you. Each category covers the entire syllabus at a time, and insightful answering tips and suggestions are also given, and it is strictly based on the latest syllabus prescribed by the council. So for each and every chapter, the different types of questions are there. Okay, so I'll just read it out for you. Word of advice for each chapter: chapter at a glance, short answers, then long answers, figure based short answers, okay, then short numericals, long numericals. All the type of numericals are also given there. Okay, so the buy link of this book or the description of this book also I will give you in the description box below. Okay, so keep your learning always on Zenith Academy Online. Do watch our part 2 for studying the second part of the sound, and we are coming up with all the parts of the chapter sound. We have videos of physics, chemistry, biology, English, Hindi, everything for ICSE class 10. So go ahead and watch them. We have series for ICSE, we have for CBSE, for state board, and also for IGSE. Okay, so see you all and keep the learning always on Zenith Academy Online. Bye bye, my dear students.